What's up, everyone? I just wanted to make sure that before we start this video that I drop off this nugget to make sure I drive this point home to understand what's going on. All right, so when it comes to completing the square, you want to have it in this form: ax squared plus bx equals c, so equaling the number. What makes this process a lot easier to handle is that if the b term, or the coefficient of the x term, is an even number. If it's not even, then I probably wouldn't use complete the square as an option. I'd use one of the other three. Because if it is even, then you're able to handle it with relative ease. All right, so I just wanted to make sure I mentioned that before the video starts. So with that said, enjoy the video. Yo, what's really good, brothers and sisters? I am your host, your brother, your professor, Mr. O'Neil Barnaby, founder and director of the Black Math Academy, here with another video showing you what intelligent black society is all about. All right, welcome to part 3 of my 4-part series on how to solve quadratic equations. In this video, I'm going to talk about the third step in how to solve them, which is called completing the square. So I'll give you guys an example to demonstrate how to go about completing the square. Yep, and just like Morse code, I'm going to decipher the code and tell you the truth. Alright, so here are the 4 steps that I've mentioned before. Pull out the GCF as the first one, the AC method is second, completing the square is third, and the quadratic formula is fourth. So we're going to talk about the third step, the completing the square. So in the past, I've told you that for most of your quadratic equation problems, you're going to want the equation in standard form to be able to solve it. If you recall, standard form is ax squared plus bx plus c equaling 0. However, since we're doing completing the square, the way to go about solving this requires a different format. So let me show you what that looks like. You're going to want ax squared plus bx equaling c. All right, so you want to notice the difference between those two so you're not confused. Ax squared plus bx plus c equals 0, and ax squared plus bx equals c. So the difference between them is that the c has been moved over to the other side of the equal sign. Here it's on the left side, and the right side is equal to 0. In this form, c is on the right side, so it's not equal to 0 anymore. So just to make it even more clear, the formula that we're going to use to go about solving quadratic equations by using completing the square is this form. Unfortunately, it doesn't have a name as far as I know, but you definitely want to put it in this form. So if all 3 values are on the left side of the equation, you want to move that number value to the right side. All right? So to give you guys an example to go about showing you, let's say you had the equation x squared plus 6x minus 16 equals 0. All right, so we've got our equation, x squared plus 6x minus 16 equals 0. All right, so like we just said, we want to put it into this form first before we can actually complete the square. So we're going to have to move the 16 over to the right side. So that means you're going to have to add it. Add 16 to both sides. All right, that'll give you x squared plus 6x equals 16. So far, so good. Now, to actually complete the square, the process is you're going to take half of the b term, then square it, and then add it to both sides of the equation. So here is the format. The b term is the coefficient to the x term. So our b is the value 6. So we're going to take half of 6, square it, and then add it to both sides of the equation. So 6 divided by 2 is 3. Then we're going to want to square it. So 3 squared. That is equal to 9. We're going to take 9 and add that to both sides of the equation. So here, the 6x, we're going to add 9 to that. And the 16, we're going to add 9 to that as well. All right, so now the result after doing all of that will be x squared plus 6x plus 9 equals 25. And there you have it. Now, what happens as a result of completing the square is that this particular side of the equation, this left side, that format happens to be a perfect square. Let me show you what I mean by that. If you were to factor this equation, or sorry, the left side, the old-fashioned way, disregarding the 25 for a moment, you find factors of 9 that add to 6, and factors of 9 that add to 6 would be 3 and 3. So when you try to turn them into the two binomials, you get x plus 3 and x plus 3, and that equals 25. So since you're multiplying the same thing twice, x plus 3 times x plus 3, another way of saying that is x plus 3 squared. So we can simplify it and just put it under one parenthesis. X plus 3 squared equals 25. You see that? And now that we have x plus 3 squared equals 25, again, the goal in terms of solving quadratic equations is to solve for x, get x by itself. So it becomes just simple algebra, and the way to solve algebra problems is to do the opposite operation to remove things and to get x by itself. So since we have an x plus 3 squared, we want to definitely get rid of that exponent, that power of 2. And the opposite of squaring, or the inverse of squaring, is square rooting. So here is where we would square root both sides of the equation. Square rooting something squared cancels each other out, and what's left is the x plus 3. The square root of 25 is positive and negative 5. Keep in mind when you're square rooting that you always get two answers. You get a positive version and a negative version of that answer. So x plus 3 is equal to positive 5 and negative 5. And now it's just simple algebra again. You subtract 3 from both sides, and that'll give us what we're looking for. So if you subtract 3, we're going to get two answers because 5 is positive and negative, so we have to treat it such. So when 5 is positive, positive 5 minus 3 is a positive 2. And if 5 is negative, negative 5 minus 3 is negative 8. And these two would be the solutions to this quadratic equation. And this is an example of how to complete the square at the same time. Just keep in mind, completing the square, once again, means to take half of the b term, square it, and then add it to both sides of the equation. Our b term was the 6 because of the format of how it looked. The b term was 6. Half of 6 is 3. 6 divided by 2 is 3. Then you square that value. 3 squared is 9. And then you add 9 to both sides of the equation, which we did, 6x plus 9 and 16 plus 9, and it gave us this part here. X squared plus 6x plus 9 equals 25. And then from there, it became somewhat simple. So the question then becomes, well, why is this even useful? I mean, we actually didn't have to solve this problem by completing the square. We actually could have just used it the old-fashioned way, the old-fashioned factoring. Originally, it said x squared plus 6x minus 16 equals 0. We actually could have just done it the old-fashioned way and said, okay, what are the factors of negative 16 that add to 6? Well, they happen to be positive 8 and negative 2. So when you set it up, it would say x plus 8 and x minus 2 equals 0. And then when you perform the opposite operation or set them both equal to 0 and just solve it algebraically, you would get x is negative 8 and 2. The same two solutions we got originally. Negative 8 right here and 2 right here. So why do we even have to have completing the square as an option? Well, let me show you. Let me use this one. At this step here, where we got this equation, disregard the square root for a moment. It said x plus 3, that quantity was squared, equals 25. Now, in that particular format, what happens to show up is the vertex of our graph. For those who don't know, when you graph a quadratic equation, ax squared plus bx plus c, when you try to graph it, it creates a U-shaped graph. So it'll look like, it'll do that. So it creates a U. At the bottom of the U, that point there where it starts to change directions is the vertex of that parabola. So within this particular part of the process of solving it, the vertex actually shows up right here. It happens to be the values of 3 and 25, but more specifically, it's the opposite side. So 3 was positive here, so the x part of the coordinate would be -3. For the 25, its opposite sign would be negative, so the y part of that coordinate point would be -25. So the vertex of our parabola would be -3, -25. This would be the vertex. Write that one more time. This would be the vertex. So we have the vertex in the graph, so we can actually pinpoint that on the graph itself. Plus, we actually know the x-intercepts of the parabola or the U-shaped graph as well. We just got them. X is 2 and x is -8. So that means in the graph itself, we can locate where x is 2. That would be somewhere over here. And x is -8. That would be somewhere way down the line, somewhere down here. And if we were to graph this thing for real, the vertex would be -3, -25. So that's somewhere way down here. That would be the vertex. And we can have a rough sketch of what the parabola or the U-shaped graph actually looks like. We've got most of the information that we need to paint a pretty good picture of what the graph looks like. So that's why completing the square is actually important, even though in this particular example, it may have taken a little bit longer to solve. But here at the Black Math Academy, we don't just tell you what you need to know or facts and information. We also tell you the truth. All right, folks, the Black Math Academy does it once again. We demonstrate why we are clear, concise, and articulate, which makes us your premier source for mathematics tutoring, which also shows that we're without peer. Don't forget, like, share, comment, subscribe, and follow all of our social media pages, Facebook, Instagram, and YouTube. And always remember that if it ain't broke, don't break it. Math is where it's at.